Hi friends, today we will see an important question of digital electronics, that is how many ways we can design an inverter, or in another way we can say how many ways we can generate clock using gate. At the last of this video, we will see how inverter is converted into clock generation circuit. First, we see how different gate is converted to the inverter. So, if we talk about the functionality of the inverter, so if input will be 0, then output will be 1, and if input is 1, then output will be 0. This is the truth table of inverter, and this is the symbol of the inverter. So first we try with NAND gate. So this is the truth table of NAND gate. Uh, at the condition of 1 1 means when input is 1 1, the output will be 0, and other combination output will always be 1. If we see the truth table in first case and at last case, we see A and B are same. This condition and this condition, when A and B are same, it act like an inverter, 0 to 1 and 1 to 0. So we make an inverter with NAND gate, like we sort the both the input and write it A, and the output will be Y. So when both the input will be 0 0, then it will be 1, and if both the input is 1 1, then output will be 0. And we have one more combination. If we see uh, when A is 1, it acts as an inverter. If A is 1 and see the B and Y, it looking like an inverter truth table. So we make one more inverter with the NAND gate, in which uh, we make A as an VCC and B as an input, and Y act as an inverter. And if you talk about the NOR gate, this is the NOR gate symbol, and this is the NOR gate truth table. Uh, Here also we can see that when both input is 0 0, output is 1, and if both input is 1 1, then output is 0. We can see in truth table. So we can sort the input and make the gate. So when input will be 0, so both will be 0. At that condition, output will be 1, and if input is 1 and both is 1 1, so it will be 0. These two condition, and one more condition we can take for making inverter, that is when A is 0 0. These two condition, when A is 0 0, whatever is the B, it is inverted as an output. So we can make a one more combination, that is A should be grounded, and B as an input. So we can say that when B will be 0, so y will be 1, and if b is 1, y is 0. So it also acts as an inverter. If you talk about the NAND gate, this is the truth table of NAND gate, and this is the symbol of the NAND gate. So we can't see any combination for the inverter. Uh, if both are 0, then it is 0, and if both are 1, it is 1, and no other combination shows inverter property. So it is not possible to make inverter with the AND gate. And same here, same in the case of OR gate. uh, if both the input is 0, at that time output is 0, and if both the input is 1, then output is 1, and in also in intermediate combination we can't make an inverter. So with the OR gate it is not possible to make an inverter. If you go further and see the XOR and XNOR, this is the symbol of XOR gate and this is the truth table of XOR gate. If both the input is same, then output will be 0, and if both the input is different, then output is 1. So for that we make an inverter with one possibility only. And that is, if one input is VCC, this case, so we can see that output is inverted. So we make inverter by making a input as VCC. So whenever B is 0, whenever B is 0, uh, we can see Y is 1. Whenever B is 1, Y is 0. B is 1, Y is 0. So it acts as an inverter. And if you talk about the XNOR gate, so we can see that only this condition it acts as an inverter, means when one input is 0 0, then whatever is the another input, that will be invert as an output. So we make one input A as an uh, ground and other input as an input. So we design an inverter with XNOR gate that looks like this is the A and this is the B. So if you see, if I see that A is 0 0, means only these two condition will satisfy. So if B will 0, then Y will 1, and if B is equal to 1, then Y will be 0. So it acts as an inverter. So by the different gate we can make inverter in 7 way. This is first way, this is first way, this is second way, this is third way, this is fourth way. And here it is no in AND and OR it is not possible to convert into inverter, and in XOR it is fifth one, it is sixth one. So now time is to see how inverter is converted to the clock generation circuit. So if you talk about the inverter, inverter is looking like this, and inverter is converted into clock by giving some internal delay, TPD, propagation delay. And also we have to make one more connection, that is feedback connection. We take an example like if I have an inverter that is 2 nanosecond delay and one feedback is connected. So if consider a previous input is 0, so it is transmitted to 0 here, and after 2 nanosecond I make a waveform that is after 2 nanosecond, 2 nanosecond, it will update, and it will converted into 0 to 1. So it become 1. And after 2 nanosecond, 1 become 0, like that. Then here after 2 nanosecond, again it become 0. Mm, and this zero is inverted. This zero is inverted after 2 nanosecond. So after 2 nanosecond, this zero become 1. So after 2 nanosecond is again, it again become 1. So we can see it is an uh, clock generation of uh, 4 nanosecond time period. So with this all inverter, all six type of inverter, we can generate a clock, and we can see by the six different combination of the inverter generation and one this inverter. By the seventh, with the help of seven inverter, we can make the clock generation circuit. I think you understand very well. If you understand, like this video. We will meet in next video. Thank you.